Hello, ladies and gentlemen. Today we're going to talk about combinations. This is chapter 15, section 11. Combinations are different from permutations because order is not important. In permutations, typically you're given jobs. You saw we had problems with batting order, people lining up. Combinations is not like that. You are picking club members. You're picking people for committees. The magic word with combination is committee. If you go to that every 15 minutes club meeting and you join, you would be a part of a combination. If you're the first person that goes in there and joins up, or the 20th, it really doesn't make any difference. You're a member of the club. If you try out for the track team and you make the track team, it doesn't matter if you're the first person that the coach put on their list or the 25th person that the coach put on their list, you're on the team. Joe, Beth, Mary, and Mike are members of a club. How many different ways can you have a president and treasurer? These are jobs. President's a job, treasurer's a job. So that's a permutation. 4p2 is 4 times 3, which is 12. How many committees of 2? Now what you're doing here is you are selecting 2 people to go off and do a little project on the side, but they don't have jobs. It doesn't really make any difference. So here's what you do. You take 4p2, which we know is 12, and you divide by 2 factorial, which is 2. Now let me clean up the factorial so if you don't have the sound turned on, like somebody I know here. There are 6 committees of 2 persons that you can make here. This is 4 choose 2. When order does not matter, you are going to use C instead of P for choose 2. The difference is you divide by the second number factorial, which means combinations are always going to be slightly smaller than the same numbers in a permutation. You will divide by R factorial. And your calculator does this work. So we can load up the calculator here so we can show you how to do this. So we'll do a couple by hand, but then we're going to show you how to use the buttons on the calculator to get this stuff done. Okay, here we go. So we have our calculator here. We can clear that off, get it ready to go. Now it's ready to go. Okay, how many 5-member committees can be formed from a 5-member club? If you have every single element of a combination being used, that is going to be 1. The reason it is 1 is because 5c5 is 5p5 over 5 factorial. Now if we work that out, 5 times 4 times 3 times 2 times 1, 5 times 4 times 3 times 2 times 1, 5 goes into 5, 4 goes into 4. Look at all these 1s. It ends up being 1. Okay. How many committees of 2 from a group of 7? You have 7 persons. You are going to choose 2 of them. That is 7p2 divided by 2 factorial. 7 times 6 divided by 2 times 1. 2 goes into 6 3 times. That's 21. Let's use the calculator to get the same answer. We type in 7. We hit the math button. We arrow over to the PRB tab, and you'll notice that NCR is the third thing in the list. We get that 7 NCR to appear on our screen, enter the number 2, and there's your answer, 21. All right, how many ways can people not be selected for the committee from example 2? Well, how many ways can people not be selected for the committee? Well, think about it. If you're selecting 2 persons for your committee, how many people are not getting selected? We can do 7c5. For every time you pick 2 people, there is 5 people that are not being chosen. So that becomes 7 times 6 divided by, times 5 times 4 times 3 divided by 5 times 4 times 3 times 2 times 1. So 5's cancel, 4's cancel, 3's cancel, 2 goes into 6 3 times, and that answer is also 21. If 2 people are chosen, that means 5 people are not chosen. 7c5 is equal to 7c2. 7c5 is equal to 7c2. You'll notice these numbers add up to be the number in front. Whenever that happens, those will be equal to each other. So if we keep that in mind, 25 over 3. Now this is a notation. This means combination. See how it's in parentheses, the numbers are on top of each other. There is not a fraction symbol. That's another way of saying 25C 23. Well, this number plus the number you add to it to get 25 are equal to each other. So that number is 2. 23 plus 2 is 25. When they are equal to each other, I mean the sum of these numbers at the end, when they're equal to the number in front, those combinations will be equal to each other. And we can verify that on the box. 25, math, PRB, choice 3. 25, choose 23 is 300. 25, math, choose, ooh, I messed it up. 25 NCR, choose 2 is also 300. So they're both equal to 300. They are equal to each other. Combinations. Order doesn't matter in the slightest. How many 4-person committees can be formed if Dr. X and Mrs. Y must be on the committee from a group of 10? Well, think about this now. You've got Dr. X and you've got Mrs. Y and 2 other unknown persons on your committee. Is it really a committee of 4? I don't think it is, because those 2 people have already been selected. So really, this is a committee of 2. And there is not a group of 10 people, because Mr. X and Mrs. Y is already on that committee. So technically there's only 8. This becomes 8 choose 2, which is 8 times 7 divided by 2 times 1, or 56 over 2, which is what, 25, 28, 28. We can verify that just so we can learn how these keys work here. 8, math, PRB, choice 3, put in that 2, and hit enter. 28. There are 6 points on a plane. No 3 are collinear. How many straight lines can be drawn? How many points are required to draw a line segment? How many points are required to draw a line segment? The answer is 2. So for those 6 points, you're going to choose 2 points to connect. That's 6 times 5 divided by 2 times 1, or 15. And we can even look at it. Look at 1, 2, 3, 4, 5, 6. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14, and where's the missing line? Find it, find it, find it. Oh, here it is. 15! Haha! 15 segments. Whew. I need stronger glasses. My glasses aren't working! Alright. For number 6. 10 boys and 20 girls. How many teams of 3 students each if you can have any 3 students? Well, there are 30 students, so keep that in mind. So of those 30 students, we want to choose 3 of them. So we do 30 choose 3. Numbers are getting big here. 30, math, PRB, go to the NCR, 3, and hit enter. 4,060. 1 is a boy and 2 is a girl. Now this is interesting. We're going to take the boys. We're going to choose 1 boy. Of the 10 boys available, we're going to choose 1 of them. Of the 20 girls available, we're going to choose 2 of them. And we have to multiply because we want this to happen at the same time. This is how you do this. You have to do this a lot. So 6B, I'm cruising through here trying to make the note short for you, but this is really, really important that you can do that. 10, math, get over to our C here, 1, which is just going to be 10, times 20, math, get over to our C here, 2, alright, and it'll do it for us. Do it all out. 1900. 1900. 3 girls. 10 boys, we're going to choose none of them. 20 girls, we're going to choose 3 of them. Now, as you can see here, 10 choose 0 is not a losing proposition. It actually, when you do 10 choose 0, it's always equal to, well, anything choose 0 is 1. There is only one way to do that. You just don't do it. That's the one way. It's weird, huh? But anything choose 0 is just going to be 1. 20, math, choose 3. Oh, gosh, look at me. 20 choose 3 is 1,140. So the answer to this is 1,140. All right, at least 2 girls. So we're making a committee of 3 persons, okay? What will make us happy is getting 3 girls or 2 girls. Well, 2 girls we already did. That was part B. That was 1,900. 3 girls we did already. That's part C. That's 1,140. If we add them together, 1140 plus 1,900, we get the answer to this problem. 3040. Least. At least. That is a hidden or statement. So be wise. Be wise to the hidden or. Okay, and that's it. You are going to have a substitute in tomorrow. Bring lots of questions and do your best. All right, I look forward to seeing you on Wednesday.